Math, it's all about math, the wonderful world of math. Welcome to the wonderful world of math, trigonometry style. We're going to do one more type of example for the cosine sum angle identity. If you'll recall, the cosine sum angle identity says that if you have the cosine of a sum of two angles, this can be expressed as the cosine of the first angle times the cosine of the second minus the sine of the first times the sine of the second. Okay? That's what we're at. Now in the last two videos, we said how to do this if you have the cosine of an angle we are not comfortable with, but that can be written as a sum of two better known angles, and you can express this in terms of the cosine and sine of those better known angles. Right? And the second video, we said, well, what if we know not the cosines and sines of these two angles, but their sum, and we could do it backwards and get something like that. This time I am going to give you neither the sum, a plus b, nor the angles, a and b themselves. This time I'm going to give you the value of some of these trig functions. I'm going to say sine of a equals negative 3/5, not a equals negative 3/5. The sine of a. And I'm not going to give you b. I'm going to give you the cosine of b. One of the things that's tricky about this is that the cosine of b can be plugged in directly for this whole thing. A lot of people, after the last two examples, want to plug in the cosine of b for the letter b. But no, the cosine of b is replaced with the cosine of b, right? It makes sense when I say it that way. But let's see how this works out in practice. Sine of a is negative 3/5. Cosine of b is 4/7. We're also told what quadrants these two angles are in, which we'll see how that works later. The cosine of a plus b requires us to know four things. To find this, using this formula, I need the cosine of a, the cosine of b, the sine of a, and the sine of b. Which of these four things do I have given to me? I have the sine of a, and I have the cosine of b. I have this and this. I do not have this. I do not have this. But because cosine and sine for the same angle are related, we can use identities that we've established previously to help us get from sine of a to cosine of a. So what kind of identities relate sine and cosine? You may say sine theta over cosine theta equals tangent theta. That's true, but it also uses a third function, and we don't need tangent, so we don't want that one. Are there any other identities that relate sine and cosine? There should be only one that we've established up to this point that will do that trick, and it's the fundamental identity, the Pythagorean identity, sine squared of an angle plus cosine squared of the same angle equals 1. So I know what sine of a is, so it should be easy to find sine of a squared. Remember that sine squared a means sine a parentheses squared, right? This can be helpful when substituting in here. What is sine of a? Well, according to this, it's negative 3/5. Sine of a is negative 3/5, so sine of a parentheses squared means negative 3/5 squared. And doing this is going to be how we find cosine of a. What I'd like you to do is I'd like you to try to simplify this on your own, solve for cosine of a. Okay? So pause this, and I'll join you in 3, 2, 1. To square a fraction, you get top times top over bottom times bottom. Negative 3 times negative 3, 5 times 5. Cosine squared a equals 1, subtracting 9/25 from both sides. Getting a common denominator now. We have cosine squared a equals 1 minus 9/25. The least common denominator between these two is going to be 25. So 1 is equivalent to 25/25. And now that they have the same denominator, I can subtract fractions by subtracting the numerators, and so on. We get 16/25. Okay, so hopefully we were able to get this far. Cosine squared a equals 16/25. To get from cosine squared to cosine, how do I undo a square? Well, we take the square root of both sides. On the left side, this becomes cosine of a, and on the right, you can think plus or minus 16 over 25 in the square root. Plus or minus. That's one of the important things that people like to forget here. When you take the square root of both sides, plus or minus the square root. And of course, in this one, I picked it so that the top and the bottom would both have nice square roots. The square root of 16 and the square root of 25. But this has two answers. This is where we need to use this information. If A is in quadrant 3, is cosine positive or negative in quadrant 3? In quadrant 3, cosine is negative. So we're going to pick this one. So now I've found cosine of A. I know sine of A, cosine B, and cosine of A. I still don't know sine of B. But since I was given cosine of B, I can use the Pythagorean identity again to find sine of B. I want you guys to try this. Pause it. Try to do it just like we did this. Okay? And I'll come back with you in 3, 2, 1. Are you ready? Here we go. We're given that cosine of B is 4/7 and that B is in quadrant 1. We need sine B, so we're going to use the Pythagorean identity, sine squared of B plus cosine squared of B equals 1. Cosine squared B means cosine B parentheses squared. You don't have to do that step, but it makes it easier for some people when they're plugging in a value for cosine B, right? If I'm going to square cosine B, I want it to look like I'm going to square 4/7. So sine squared B plus 4/7 squared. Notice that cosine B, that whole expression cosine B is equal to 4/7. Yeah? Okay. So this is when we get sine squared B plus 16 over 49 equals 1, and we subtract 16 over 49 from both sides, just like we did last time. And we get a common denominator. And when we subtract 16 from 49, we should get 33. So this is sine squared of B. What is sine of B? Like last time, we're going to take the square root of both sides. And like last time, we have to say plus or minus. Taking the square root of the top and the bottom separately is a good idea because you can take the square root of the denominator and the numerator is going to stay this way. Now, how did we choose plus or minus last time? Last time we looked at the quadrant. This case, B is in quadrant 1. So is sine positive or negative in quadrant 1? Everybody's positive in quadrant 1. So we're going to say plus. So sine of B is positive root 33 over 7. So coming back to the cosine of A plus B. We were given a bunch of stuff and we found out a bunch of stuff. We found out that sine of B is positive root 33 over 7. So there's one. We were told that cosine of B is 4/7. So there's 2 down. Going back further, we were also told that sine of A was negative 3/5. Sine of A is negative 3/5. That's 3 of them. And we found out that cosine A was negative 4/5. Because it was in the third quadrant, A, these two were both negative. Okay, so we found each of these things that we need. We found the 2 factors for this term, and we found the 2 factors for this term. So let's put everything in. Cosine of A plus B is equal to the cosine of A. Now again, this does not say A equals negative 4/5. It says cosine of A equals negative 4/5. So I'm not replacing the letter A. I'm replacing the entire cosine of A. Negative 4/5 by itself times the cosine of B. And the entire cosine of B, not B equals 4/7, cosine of B equals 4/7. So this whole thing is getting replaced with 4/7 minus sine of A. The sine of A is negative 3/5. Not A equals negative 3/5. The sine of A. So this whole thing is getting replaced with negative 3/5. And over here, sine of B, the whole expression is equal to this radical. So we're going to have radical 33 over 7. Because I replaced the entire cosine of a with -4/5 because this was the value of that function at a. I no longer have sines and cosines. I used cosine to take a to this ratio. I used cosine to take b to this ratio. So at this point, we just have to realize that we're almost done. It's just arithmetic left, multiplying, multiplying, and subtracting. Multiplying these two fractions means top times top over bottom times bottom, and multiplying these two fractions, noting while we're doing it that negative and negative make a positive. Top times top, there's nothing we can really do here because this is inside a radical. It's just going to be 3 times radical 33. But in the denominator we can get 5 times 7. And notice that these guys have a common denominator, so if we like, and we do, we can write this as one fraction with a sum in the numerator. And that's our answer. Hooray! So for our next example, we want to do more or less the same idea. Let's say we want cosine of a sum of these two angles a and b, and we're given that cosine of a is -2/5, cosine of b is +3/4, and we're also told that a is in the second quadrant and b is in quadrant 4. Okay, so like last time, we know that to find cosine of the sum of these two angles, I've got to use the cosine sum angle formula. So cosine of a, cosine of the first angle, times cosine of the second angle, b, minus the sine of a times the sine of b. And you'll notice that, like before, I was given 2 out of these 4 trig values. So I've got to use cosine a to find sine a, and I've got to use cosine b to find sine b. Try and look at the last example and see if you can come up with what to do next. Okay, pause it and work on it. And come back. Meet you back in 3, 2, 1. Here we go! Last time we used the Pythagorean identity to take cosine and tell us about sine. If cosine a is -2/5, then cosine squared of a is going to be -2/5 squared. We still don't know sine squared, so this is unknown. Over here, we're going to square this fraction, top times top, -2 times -2, and bottom times bottom, 5 times 5. Right? And then we subtracted 4/25 from both sides. Sine squared a equals 1 minus 4/25, getting a common denominator that's 25 over 25 minus 4 over 25. 25 minus 4. Sine squared a is 21 over 25, which means that sine, what did we do next? We took the square root of both sides, and when you do that, you got to say plus or minus. The square root of the top can't be simplified, but the square root of bottom is regular 5. Now how do we choose whether we say positive or negative square root? The answer was the quadrant. Cosine is negative in the second quadrant. Now what about sine? Sine is positive in the second quadrant. So sine of a is positive radical 21 over 5. And then we do this. If you didn't get this one the first time, here's your chance to pause this and work on this side. Try it. 3, 2, 1. Here I go. I hope you guys paused it and got a good head start. Cosine of b was given as 3/4. So this is cosine b parentheses squared. That means 3/4 parentheses squared. And when we square it, we're going to get 9 over 16. And when we subtract that from both sides, we get sine squared of b equals 1 minus 9/16, which is 16 minus 9/16. Sine squared b is equal to 7/16, and we take the square root of both sides. Sine of b is plus or minus the square root of 7 over 16. Taking the square root of the top and the bottom separately, the square root of 7 can't be simplified, but the square root of 14 is nice. And there's that. Cool, right? Now, do we choose the positive or negative square root? Based on the quadrant, what would you say? B is in quadrant 4. We're looking for sine. In quadrant 4, sine is negative. So putting all these things in a row and reminding ourselves what we wanted. We wanted cosine of A plus B. Using the cosine summing formula, we know that we've got to replace cosine A with the value of cosine at A. So this is going to be negative 2/5 times cosine of B. Cosine of B is equal to 3/4. Notice that B is not equal to 3/4. Cosine of B, all 4 letters, equal to 3/4. So all these 4 letters are replaced with 3/4. Minus sine of A. Sine of A, radical 21 over 5. Sine of B is negative radical 7 over 4. Okay, so now we just have to simplify. Negative 2 times 3, negative 6. 5 times 4, 20. Here we have negative times negative becomes positive. And this is going to be square root 21 times square root 7. You can multiply this together, and you should get 147. But we're going to talk about this a little bit more here. Maybe if you're going to look for the square root of 147, and if you think you might want to reduce that, you do. Maybe before multiplying 7 and 21, maybe we should factor it. Because what we're going to do is we're going to then sit down and ask ourselves, are there any perfect square factors of 147? If we factor 21, over here, look on the side, 21 equals 7 times 3, right? So when I multiply 21 times 7, I'm really multiplying 7 times 3 times 7. That's the same thing, right? Except that you notice that there are 2 7s this way. So when I multiply 21 times 7, this is the same as multiplying 49 by 3, and this is a perfect square factor. Noticing that stuff ahead of time can make it easier to explain how we're going to simplify this. You should also notice that this reduces if you want. If you want. And you can do that, or if it's your preference to get a common denominator, you can do that too. I'm going to reduce this right now. They both have a common factor of 2, negative 3/10. And this square root is the same as this square root. So negative 3/10 plus the square root of 49 times the square root of 3, 7 radical 3 over 20. That's our answer. Tarbo-tastic! Our word of the day today is Tarkia, the brainy one. It's a dinosaur that looks a lot like an ankylosaurus with a totally different name. This has been a Badger Bear production of The Wonderful World of Math.